From the bathroom. He says bathrooms are the biggest water guzzlers. His idea is to reclaim some of that water and reuse it. Although the idea may not be all that original, the system that makes it work is.
30% of water going down the toilet drain every time you flush. The shower takes about 30 to 40 gallons per person. The bath takes even more. In this position, the green light indicates that the unit is ready to recycle.
Once you flick on the switch, it starts working. Jones gave us a demonstration. The draining water from the bathtub is channeled into a chlorination tank. From there, it's pumped upwards and filtered not once, but twice. It's then pumped into a holding tank. This reclaimed water can then be used for flushing toilets and watering the landscape.
If you can selectively choose those waters, the fresh water that goes down your waste, and reuse it in a sense. Like I haven't used dirty water, fresh water in my toilet since January of this year. All of the water's been reconditioned water, reclaimed water.
Jones has been tinkering with his invention for more than 2 years now. He calls his unit a water monitoring system, or just WMS. He's gone through 3 prototypes to make the system perfect. But what Bay Area residents may love most about WMS is the fact it enables them to water.
Hi. The previous interview was conducted on May 14, 1990 by Penny Nikamura of Channel 11 KNTV San Jose News Team. I hope you enjoyed it. The following information is a little bit more detailed information on my product, the WMS 2000, the water monitoring system.
My name is David Jones, and I want to introduce to you my new invention. It's called a water reclamation canister, or basically a liquid waste can. It's a wastewater monitoring system. It monitors all instances of water that we waste in a shower, in a restaurant. This is the book that I wrote about it. I used the title, The Aftermeal, because the word aftermeal is all encompassing. It encompasses insects that crawl upon the earth's surface. It encompasses single-use items, the straws, knives and forks, the plastic single-use items, condiments, and the cups. In this book, I describe a little bit more about this product. This book was published in 2017. I've been writing and conceiving about this product for the last 20-something years. I've been working on it. This product is a combination of a waste management system, water reclamation, and water recycling systems all combined in one. This is the cover. I'm gonna just take it off. It represents chamber 1, where most of the ice is collected and potable water is collected. For example, every time you go to a restaurant, the waitress gives you that water with ice in it that you don't drink. After you don't drink it, this is the kind of a machine, a liquid waste receptacle that we need. We take our cup, empty it out, and stack the cup up. If the cup has ice in it, you pour it in Wally Well's mouth. Wally Well separates that ice from the machine, the cup. If you are drinking milk, for example, you pour it in. Once you get it, and the ice that's in the milk would separate. And if you had a straw in your cup, you take your straw out and stack it separately. You'd empty your cup into Wally Well's mouth. The ice separates, comes into chamber 1, and you stack your cup. So what we've got is all the straws, knives and forks and condiments, single-use items stacked up through the top. And a little orange juice I hate to throw this away, but that's how we do it. So this is the system without the covers. This is what it looks like. And a little peep inside, you see the ice that we separated. It's the back of the unit. So the unit has input and output valve. That blue tube is connected to the sewer. The green line are input and the other line is output lines. And they're connected up to our demo. This would represent the storage tank, empty right now. This would represent, say, a kitchen sink, where everywhere we collect water, a tub. What if this was a shower, for example? We would be collecting water. We put sensors in here. We've got laser sensors, optical sensors that'll tell us if the water's cloudy or not. If it's cloudy, we let it go into the drain. If it's clear, straight gray water, we'll recycle it to this tank. Here's a slight demo of how the shower would work in the future. Okay, scene comes on. It actually starts cleaning out this section. It sends water down there for 30 seconds and it'll clean this section out. Then it starts acting on the ice. For 1 minute, the machine is going to process this ice, melting it, cleaning it out, and melting the ice. Once the ice is all melted, in about a minute or two, it'll start processing the water and kicking out nothing but clean water to the holding tank. After the storage unit has so much water in it, the system will sense that by floats that control the water level in this storage unit, and it'll start pumping the water out into the lawn via our sprinkler system, which is working. That's because of this storage unit overflowing. That's what happens to the water. And that is our little demo. Happy saving your water from your shower. Here we have rain barrels connected to the system as well. They can be controlled by switches, which turn this system on and starts the process of collecting rain barrel water. Okay, we are looking at the program that controls the machine. This machine runs a program, and this is the circuitry. We can control this machine and tell it what to do, what devices are connected to the system, and we can control input and output to all of those various devices via this program. This program can be accessed via the internet, and this unit will become a part of a network. All of these units will become a part of a after-meal network where we monitor your input to every device concerning wastewater in your building or business. We can connect up to salad bars, water barrels that contain ice with the sodas in them, all of the devices that a business uses in its restaurant that uses an ice and has wastewater can be controlled and manipulated by the system. And this is the machine. And this machine is totally programmable and can be interfaced from the web so that we can remotely monitor and control every device in the home that this machine is connected up to. This is the base, bare necessity for an intelligent home. Intelligent homes must be ones that can dictate and mandate what happens with water, gray water. My name is David Jones.